Good day, everyone. I'm Brian. I'm doing the AI product management course, and I work in agriculture, and I have done my presentation for the third case study. The product I would like to present is an AI-assisted soil analysis and fertilizer recommendation tool we are developing in my company, and I will use it as an example to define the topics we have seen in this course. In simple terms, there are some countries around the world, for example Africa, in which soil testing is not a common practice, and farmers are exposed in fluctuation of fertilizer prices, which means that they are never sure if it's a good choice to fertilize the soil, how much, and which type of fertilizers. And we have also seen recently, because of war, how much fertilizer price can be affected. When you don't fertilize the soil, you will have less yields. And as you can see in the image on the top right. And when farmers continue to not fertilize the soil, they enter in a process called soil mining, and that causes like a poverty trap. Farmers becomes more and more poor. So our proposition is to design a tiny laboratory service that can access every field in Africa and use a specific technique called soil spectroscopy, which means we analyze soils with light. So we use a scanner, we position it in the soil, we create a radiation of the NIR spectra. The soil will create a unique spectral features, which will be dropped in a convolutional neural network. And the convolutional neural network is capable of matching peaks of the spectra to nutrient compositions in the soil. The farmer is then capable of having a soil report in real time, in which there is specified the current soil status, so how good are the nutrients in the soil, and what is the best fertilizer recipe to be added to the soil to achieve a certain yield target. So conventional soil analysis in Africa exists, but it is extremely expensive and is really slow. It requires collecting samples and sending them to the accredited laboratories. It requires a lot of time, it's expensive, farmers have really low adoption of that, and because of that we have the problems I mentioned before happen. There is a need of a better way, and the challenge is to accurately estimate soil properties directly in the field. This is because we also want to engage with the local community and stay close to them. The signature of the soil is measured by the handheld scanner and is provided a rapid fertilizer recommendation. So as I said before, the current workflow is like this. This is a visualization developed by a cooperative called Mercy Crop, sponsored by MasterCard Foundation. And they explain the hurdles that people see when they have to perform a soil sample. You see that there are some steps to be followed: awareness, commitment, perform a soil test, receive a recommendation, and implement the recommendation. But there are also some road blockers in red. For example, the farmer is not aware, there is not enough funds, or there is a lack of follow-up after the commitment, or there is too much time between the output of the laboratory and the time of planting. The farmer has to rush and cannot implement anymore the recommendations. Or, for example, the farmer does not know how to interpret the results, and no change happens in this soil. This soil remains unfertile, and we want to remove these road blockers. So, for example, with the scanner, we could at least remove a few, such as reducing the time needed between a sampling and the result, and implementing recommendations immediately. The alternative workflow we propose is then you bring the scanner in the field, you take a soil sample, you obtain the spectra. If you are offline, you can store the spectra and keep it in the phone. If you are online, you can shoot the spectra group directly in the cloud. The machine learning model will predict soil properties in real time and send the result to the phone, or as a PDF, or as an Excel, or via API. Then the fieldman, which operates our machine, can help the farmer make the best decision. To make the soil sample, of course, we require some input from the user. The most obvious one is the soil spectra. But to fine-tune the recommendation for them, we also require them to share the crop type, the yield target, the GPS location, because we are also using satellite covariates to improve the prediction, and also a small client questionnaire. The output we provide are then the nutrient prediction and the fertilizer recommendation. We have some, you can see also some images on the right about this. For example, the top left is the questionnaire steps. On the top right is the scanner testing in the field. On the bottom left, you see the classic report from the phone. Now, entering the topic of transparency and the uncertainty, some more skilled clients, for example, multinationals or farmer cooperatives, are also curious to know the performance in predicting soil properties with our technology. And if they are capable of handling a complex scientific topic, we are ready to share accuracy documents, but we also have an internal, more advanced accuracy dashboard in which we can present multiple metrics and also be transparent about our performance. But with a common client, we focus more about outcome. So we discuss how much money have you saved by adopting our fertilizer recommendation, or how much yield gain did you have after implementing our recommendation. So we discuss topics which are more impacting their operation rather than raw accuracy metrics. People can understand that when you have this kind of data, especially at large scale, because we have a current network of 5,000 scanners globally, and some scanners are used also by big agricultural multinational. When you have a massive amount of data, a massive amount of soil spectra, a massive amount of GPS location, crop types, user account, yield aggregates, people can start to perform some market speculations and yield estimation. So corporates could use this kind of technology to track aggregate yields from cooperative and decide on price agreement in advance with them, which would ruin their bargaining and contracting balance in between them. Therefore, for example, we have some obligations. We try to protect farmer productivity data, exact field location data, and every commercial sensitive information. We follow GDPR requirements, in which also we allow the client the consent to visualize his data, the right to delete his data, the right to minimize his own data, and encryption of his data. We also provide some standard documentation about it. Regarding ethics, while we are also transparent that this technology requires calibration, because the machine learning models are trained from soils that we have managed to collect. And some soil have been less represented across the world. And for example, what we explain to the client is that we could achieve this performance with the example we have seen, but it is possible that it's not yet applicable to your specific soil dataset, and we need to integrate the specific observations from your case. And we explain the limitation of the tool. We also, to be fair, we perform some regional validation, so we provide competitive offer to the client to integrate their soil in our massive soil bank database. And also we tend to give the recommendation to agronomists, which can help to interpret the results in a better way and maybe tailor them to the local practice. For example, a potato farmer from the Netherlands might use different fertilizer amounts than a potato farmer from Kenya, and dealing with the local advisors help us to provide the best advice to be accepted by the local clients. That allows us to be accountable. Regarding transparency, as I said before, we provide confidence score of the prediction. We can explain how do they affect the important variables, but also at the end of the report, we provide a disclaimer, which means that we provide an indication or an advice of what the soil could be, and that cannot replace full agronomic expertise. Well, thank you so much for your time. I hope I have entertained you, and best of luck in the course.